Okay, so we're looking at simultaneous equations. Now there are a number of different ways that you can approach the solution of a pair of simultaneous equations. In this video clip I will use just one method, and if you're not very confident when it comes to your algebra or making decisions, then that's probably the safest thing to do, just to learn one method. So the way that a pair of simultaneous equations is set up is that you have two unknown variables, usually an x or a y, but it could be any other two letters, and in order to find a pair of numbers that satisfy an equation, you actually need to be given two sets of information. So you need, for two unknowns, two equations. And the method that we will use is called the elimination method. What we do is we do something to each of the equations to make the x terms the same. Once we get the x terms the same, we can then eliminate them from the equation and find out what value of y is. Then we substitute that back into one of the equations and work out the corresponding value for x. So that's the method that we will use every time. So it's always a good idea to number your equations when solving them. So we'll call that one equation 1, and we'll call that one equation 2. Now, in order to make these numbers the same, what we do is this: we take the first equation and we multiply everything in it by the number that's in front of the x in the second equation. So we're going to multiply that whole equation by 3, and what I'm going to do here is just show the examiner what I'm about to do. So I'm taking equation 1 and then multiplying it by 3. When I do that, I get 3 times 2x is 6x, 3 times 3y is 9y, equals 4 times 3, which is 12. And then I multiply the second equation by the number in front of the first x. So I'm going to multiply the whole of the second equation by 2. So equation 2, I'm multiplying by 2. And then I get 2 times 3x is 6x, 2 times 4y is 8y, and 2 times 8, which is 16. Now what that does is achieve the first aim, which is to make these the same. Now that I've created two new equations, I will label those equation 3 and equation 4. Now what we're going to do now is to subtract the bottom row away from the top row. So we're going to do 6x take away 6x, which is 0, so that's gone. 9y take away 8y, and 12 take away 16. So again, here I'm going to write down for the examiner what I'm about to do. So 3 take away 4. 6 take away 6 is 0. 9y take away 8y is 1y, or just y. And 12 take away 16. Now we have to do this in the right order. So 12 take away 16 is a negative answer, and it's negative 4. So y, 1y, or y, equals negative 4. So right, therefore, 3 little dots, y equals 4. What I now do is I need to work out what the corresponding x value is. So in any one of these equations, but you usually pick the easiest one, so I'm going to pick equation 1, because there's only two x's in that, and instead of having the y, I'm going to replace it with the value that I know it is. So I'm going to write substitute y in 1. So I'm substituting, instead of having the variable y, I'm going to replace it with 4. But what you have to remember is, in algebra, the 3 and the y are joined by a times. We don't put it in because it looks like an x, but when we replace the variable with a number, so it becomes arithmetic, then we put the times back in. So So a really common mistake there would have been to write that as 2x plus 34. It's not 34, it's 3 times 4. And it's negative 4, I forgot that, sorry, mistake there. 1y is negative 4, y is negative 4, so I'm replacing that with negative 4. And that is equal to, in equation 1, 4. Now, it's important before you practice simultaneous equations that you master ordinary linear equations where there's only one unknown, because that's what the problem now becomes. So we have 2x. Now here I've got positive 3 times negative 4. Positive times negative, you should know, is negative. So I get 2x negative 12 equals 4. So now we have a standard linear equation to solve. First thing I need to do is deal with that negative 12. To get rid of a negative 12, I do the opposite, which is add 12. If I add 12 to this side, I have to add 12 to the other side as well, giving me 4 plus 12. So adding 12 to both sides removes it from that side and it appears on the other. So 2x is 16. To get the x on its own, I have to deal with the 2. The 2 is joined to the x by a times. Remember, it's not written in algebra. So I have to do the opposite of multiplying by 2, which is dividing by 2. In algebra, we write divide like that. 16 divided by 2 is 8. So, therefore, the solution to this pair of simultaneous equations is x equals 8, y equals negative 4. Now the way that marks are awarded for this, these questions are usually worth 4 marks. The first mark is for getting you down to having a pair of equations where you can eliminate a variable. So we eliminated x. So there'll be a method mark for doing that. There'll then be an answer mark for getting y equals minus 4. The third mark will be for substituting in and creating an equation with just the one unknown. And then the final answer mark is for getting 8. And if you've got plenty of time in the exam, you can always check these answers are correct. So if I just do a little check over here, because what this is saying is these two values not only will make this equal to 4, but putting the same values into this equation will make the answer equal 8. So that means I'm going to have 2 times 8 for 1 plus 3 times negative 4. Well, 2 8s is 16. That becomes negative 12, and 16 take away 12 is 4, which is what that is. So that one works. Now I need to check in 2. So 3 times 8 plus 4 times negative 4, and that's 24 take away 16, which is 8, which is correct. So I know, I'm completely confident that I have earned 4 out of 4 with that, because my method is clear and I've checked it in the spare time that I've got and I know it balances. Now that method is the only method I'm going to use to work with all of these questions. That sometimes makes the maths a little bit harder, but as far as the method that you learn and what you have to remember, you know it, you've learned it already. So let's go through it again. Label your equations 1 and 2. You're going to multiply the first equation by the number 5 every term, and the second equation by the number 4 every term. And I'm going to write that down. So equation 1 multiplied by 5. So that's going to be 20x plus 10y equals, now if you're not sure, because this is likely to be on a non-calculator paper, what 17 lots of 5 is, do it somewhere else. 17 times 5, 5 7s are 35, 5 down, carry the 3, 1 5 is 5, and 3 is 8. So that's equal to 85, equation 3. And I'm multiplying equation 2 by 4. So it's going to be 20x, which is good because I want those to be the same, plus 4 times 3 is 12y is equal to, so you double that, you get 46, you double it again, you get 92. Now I'm going to do the subtraction. Again, it depends how confident you are. The sensible thing to do here would be the numbers on equation 4 are all bigger than the numbers in equation 3, so you would take the top row away from the bottom. But that's a decision. We're not talking about making decisions here, we're repeating the same process. So we're going to do 3 take away 4. 20x take away 20x is nothing. 10y take away 12y is negative 2y, and 85 take away 92 is negative 7. So because of the decision that I've taken, that has made the arithmetic a bit trickier. You've got to make sure that you've got those negatives. Now, to get the y on its own, the negative 2 is joined to the y by a times, so the opposite is dividing by negative 2. So that's another place where it's easy to make a mistake and changing that sign. So we're doing negative 7 divided by negative 2. Two negatives divided make a positive, and that comes to 7 divided by 2, which is 3.5. Once we've done that, we're now going to put that into equation 1. So 4x plus 2 times, and instead of y, 3.5 equals 17. 4x plus 7 equals 17. Deal with the add 7, you've got to take it off both sides. So 4x equals 10. 4 and the x are joined by times, opposite is dividing. 10 divided by 4, which is 2.5. So therefore x equals 2.5, y equals 3.5. And again, you could plug those back in and check that they balance in the same way I did in blue above. Marks, 4 marks, 1 mark for getting that set of equations, 1 mark for getting 3.5, 1 mark for that substitution, 1 mark for getting 2.5. Okay, let's see what's different this time. Same start, 1, 2. Equation 1, we're going to multiply by 5. So we get 15x plus 20y equals 5 times 6 is 30. Positive times a negative, signs are different, answer's negative. Negative 30, that's my equation 3. Equation 2 now, I'm going to multiply by 3. 15x, they're the same, that's what we want. 3 times 3 is 9. 1 times 3 is 3. Now we're subtracting, and again we'll stick to the method. 3 take away 4, top line take away bottom line. 15x take away 15x, gone. 20y, take away 9y, 11y. Now, negative 30, take away another 3, that takes us to negative 33. We're going down the number line another 3. To get the y on its own, we have to shift the times 11. Opposite of timesing 11 is dividing by 11. And 33 divided by 11 is 3. Negative divided by a plus. Signs different. Answer is negative. So y equals negative 3. Let's put that into... Now I'm going to pick the second equation to put that into, so I don't have to worry about that negative sign there. So substitute in 2, 5x plus 3 times, instead of y, negative 3 equals 1. Plus times negative, signs different, answer's negative. 3 3s are 9, equals 1. Now I got to deal with getting rid of a negative 9. How do I get rid of it? Add 9 to the other side as well. So 5x is 10, so x is 2. So therefore x is 2, y is negative 3. Okay, so I did do something slightly different there. I just chose to substitute the value of y into the second equation because it didn't have any minuses in it. And generally, you don't like dealing with minuses. Next one, same again. Equation 1, equation 2. 1 times 2, 10x, 4y, 20. That's my equation 3. Second equation, I'm going to times by 5. 10x, they're the same, that's what I want. 15y equals, and this time we've got 5 7s are 35, plus times a negative, signs are different, answer's negative. Okie dokie. Now we're going to do 3 take away 4 like we always do. 10x take away 10x, gone. 4 take away 15 means that we're starting at 4 on our number line and we're going negative, negative, negative down 15 places. We're going to end up at negative 11. And on this side, it looks like it's going to come up with a nasty answer. Hang on, let me just check I haven't made a mistake here. 10x, 4y, 20, 10, 15, 35. Negative 11. No, seems to be that's the case. Right, now this side, when we no, it is going to work out okay, sorry. When we do 20 and then we're subtracting a negative, then that's where we have this change, because what we're doing is 20 take away negative 35. Well, that, if you're subtracting a negative number, that's the same as adding. So that becomes 55. So you need to have a reasonable grasp at dealing with negative numbers. 20 take away negative 35 is the same as 20 plus 35, which is 55. Now it's the bond that we're breaking is the times, so we have to divide both sides by negative 11. (11) into 55 goes 5 times. Positive divided by a negative, the signs are different, the answer is negative. so y is negative 5. So there's a few things in there you have to be careful about dealing with negative numbers confidently. We're going to put that now back into equation 1. (5x plus 2 times negative 5 equals 10). 2 times 5 is 10. Signs are different. Answer's negative. To get rid of the negative 10, I've got to add 10 to both sides. To get the x on its own, I've got to get rid of the times 5 by dividing by 5. So x equals 4. Therefore, x equals 4, y equals negative 5. So if you're lucky, you're going to get a question where everything is plus signs, but you do need to be careful and you do need to be confident in dealing with negative numbers with these questions. Okay, next one. Equation 1, equation 2. We're going to multiply equation 1 by 5 and get 15x plus, brain's gone dead, 20y equals 5. That's my equation 3. 5 3s are 15, 5 4s are 20, 5 1s are 5. And equation 2, we're going to multiply by 3 and get 15x minus 3 times 4 is 12, plus times negative, signs different, answer's negative, and that is going to be 3 times 23, which is 69, and that's equation 4. Now we do 3 take away 4. Careful with our negatives. 15 take away 15 is nothing. Here again, if I just do it over here in a bubble, I've got 20y take away negative 12y. If you're subtracting a negative, it's the same as an add, so that becomes 32y. So this bit here is what's happening there. So I get 32y is equal to, and it's 5 take away 69, which is negative 64. So 32y is negative 64. To get the y on its own, I have to divide by 32. 32 is into 64 twice. Signs are different. Answer is negative. So y is negative 2. I'm going to put that in equation 1. So I get 3x plus 4 times negative 2 equals 1. 4 2s are 8. Signs are different. Answer's negative. Deal with the negative 8. How do I get rid of it? Add 8. Got to add 8 to the other side as well. So 3x is 9. Deal with the times 3. How do I get rid of it? Divide by 3. So x is 3, y is negative 2. Now, you may be curious to see why this particular question is worth 1 mark fewer than all the others. Well, the reason for that is to do with the fact that there's a much quicker way of answering this question, because the y letters, the y variables, are already the same coefficients, the same numbers in front, and because one of them is positive and one of them is negative, the quickest way of solving that particular question would be to have added equation 1 and equation 2 in the first place. If I just do that up here, just to show you, 3x plus 5x is 8x, plus 4y, take away 4y is 0, and 123 is 24. So that comes straight out of it. You don't have to do this multiplication part. So x is 24 divided by 8, which is 3. So if you get more confident at them, you can look to see if perhaps it's not dealing with the x's that's always the best. But if you're in any doubt, just learn one method and it'll work every time. It's not necessarily the fastest. And number 21, 4 marker again. And I will show you a shortcut method for this as well, but let's do it the standard way first of all. Equation 1, equation 2. Now, if there's no number in front of the x, it means that in fact there is a 1 there. So I'm going to multiply the first equation by 1 and the second equation by 2. So equation 1 multiplied by 1, which basically means it's the same, it's unchanged. But I'll call it equation 3 anyway. And equation 2 I'm going to multiply by 3. 3x plus 9y equals 3 2's is 6. Positive, negative, signs are different, answer's negative. That's my equation 4. Now I'm going to do 3 take away 4. 3x take away 3x, gone. Negative 2 take away another 9 is going to get me down to negative 11y. And that's going to equal 16. Subtracting a negative, remember, now makes that a plus in the same way as it did up there. So that's going to be 16 plus 6, which is plus 22. To get the y on its own, I have to break the times negative 11 by dividing by negative 11. 22 divided by 11 is 2. Positive, negative, signs are different, answer is negative. Now I'm going to put that one in equation 2 because that's already just got 1x. So 1x plus 3 lots of negative 2 equals negative 2. Always write in your substitution before you work it out. 3 2's is 6, signs are different, answer is negative. To get the x on its own, I have to deal with getting rid of a negative 6. Doing the opposite of that is adding 6. So on my number line, I'm at negative 2, I'm adding 6, I'm going up the number line 6 places, I end up at positive 4. So x is 4 and y is negative 2. Now an alternative method for this, which if you're watching this and you're doing higher tier, would be a method you may have learned called rearranging. And it's only really useful if you've got one of the letters where it's just 1x or 1y. So an alternative from what we've done above, if you're in intermediate tier, probably move on from this one now, don't worry about it. If we did from 2, to get the x on its own, I'm going to take get rid of the plus 3y by taking 3y off, and I have to do that to both sides. So I've rewritten x plus 3y equals negative 2 as x equals negative 2 take away 3y. That's my equation 3. And I can substitute now in the first equation, rather than writing x, I can replace it with that. So 3, instead of x, take away 2y equals 16. So I've rearranged the second equation to give me x equals, and then in the first equation, in 1, rather than writing x, I can write it now as 2 take away 3y. So what I've done is I've eliminated the x from the equation, and I've got an equation with just y's and numbers. When I clear out a bracket, I'm multiplying whatever's outside by everything that's in. So 3 times 2 is 6. Signs are different. That's positive, that's negative. Answer's negative. 3 3s are 9. Negative again. That's got rid of the bracket. Take away 2y equals 16. I'm going to deal with that number and simplify that. So I'm going to add 6 to both sides. Negative y, take away another 2y, gives me 11, negative 11y. So we end up in the same place as we did up there, with y being 22 divided by negative 11, which is minus 2. If you were in the higher tier and you were likely to be going on to further advanced maths, that is a method that you will use more and more and more. This method you won't use very often at all. But if you're in the intermediate tier, that is probably a much more straightforward method to use. Okay, we've got 2 more to have a go at. Equation 1, equation 2. Equation 1, we're multiplying by 3. So we get, no we're not, we're multiplying by 2, I beg your pardon. We're multiplying that equation by that number. So we get 6x take away 8y equals 44. And the second equation, we're multiplying by 3. 6x plus 9y equals minus 24. Equation 3, equation 4. We're going to take them away. 3 take away 4. 6x take away 6x, gone. Minus 8y, negative 8y, and then we're taking off another 9, plus 9. So negative 8y on the number line, and then going down another 9, we end up at negative 17. This side, 44, we're subtracting a negative number, means it's the same as adding, so that's the same as 44 plus 24, which is 68. So this becomes y equals 68 divided by negative 17. Double 17 you get 34, double that you get 68. So that goes in 4 times, and it's a positive divided by a negative. The answer is negative. Put that in equation 1. 3x take away 4 times negative 4 equals 22. Negative times a negative is a plus. Signs are the same. The answer becomes positive. Now to get rid of the plus 16, subtract 16. So 3x is 6, so x is 2. Therefore, x is 2, y is negative 4. And the final question, 1, 2, we're going to multiply the first equation by 6. So 6 4s are 24, 6 3s are 18. That's positive, that's negative. Answer's negative. 6 9s are 54. We're going to equation 2, we're going to multiply by 4. So we get 24x minus 20y equals 20. 3 take away 4. They have gone. So let's deal with this one now. Negative 18, and I'm taking away negative 20 minus, if you're subtracting a negative, it's the same as adding. So that's going to be the same as, I'll just do it over here, minus 18y, take away minus 20y. That's the sign that changes. So I'm at negative 18 on the number line, I'm going up 20, I end up at plus 2y. So 24x take away 24x is gone. Negative 18, subtract a negative makes it plus 2y equals 54, take away 20, which is 34. So y is 34 divided by 2, which is 17. Put that into number 1. Sub in 1, 4x take away 3 lots of 17 equals 9. 4x take away 3 lots of 17 is, not sure, work it out as a little multiplication sum. 7 3s are 21, 1 3 is 3, add 2 is 51. So 4x take away 51 is 9. How do I get rid of a negative 51? Add 51. Well, you've got to do that the other side as well. 9 add 51 is 60. X equals 60 divided by 4 to get rid of the 4 connected to the x. 60 divided by 4, half it and half again equals 15. So x equals 15, y equals 17. So for all of those questions, I have used the same method. And if you struggle with remembering methods, that's the only one to remember. You multiply the top equation by the number in front of the x in the second one, and the second equation by the number in front of the x is the first. Then subtract your two new equations, solve it for y, substitute that back into one of the originals to get the corresponding x. And the only thing you have to have a good grip on is dealing with subtracting negative numbers and remembering that when you subtract a negative, it becomes equivalent to a positive. So hopefully that has been of use to you.